Okay, this video I'm calling Miscellaneous Interesting Things in Python 3. So some of these are tricks, some of them are shortening your code, some of them are just interesting things that you can do with Python. So the first is called an in-place swap. And kind of a funny story from years and years ago. I was in graduate school and I was a teaching assistant for a class, and the lady that was the primary instructor for the class had a student in her office, and he was having trouble figuring out how to swap values of two variables. And he just couldn't understand that at the time in the language being used that you had to have a temporary variable so that you could ultimately swap those two. So what happened is she was getting really frustrated, and she grabbed a little plastic tape dispenser and a stapler and put them on the desk in front of the student and said, swap those. And he goes, okay, put the stapler where the tape dispenser is. So again, she's very frustrated. She picks up the stapler and she just smashes the tape dispenser and shatters it. And the student goes, oh, I guess I should have moved the tape dispenser first. So, the student got that, and out of her frustration, it turned into kind of a funny story. Well, Python has it so that you don't require a temporary variable to move one of them out of the way to do the swap. So here's some code. I set A to 2, B to 4, and then I say A comma B equals B comma A, and then I print out A and B, and indeed they do swap their values. So the user doesn't have to worry about having a temporary value and saying move A to the temporary value, move B to A, take the temporary variable value and store that in B. You can simply do it as the code shows there on the screen. The next thing is sometimes you want to construct variable names or variables on the fly. That is, build the name out of a string or out of a loop variable. And one thing that we recall very early on, I think I talked about the locals and globals function, and these are used to show the current values of variables within your program. So, for example, if you print locals, it's going to show you all the local variables and their values in your current program or in your current shell, Python shell. So what we can do is we can build variable names like this. So I have a loop that's going to iterate I through 0, 1, and 2. And then what I'm going to do is I'm going to call the locals function, and then I have in square brackets the string I plus the string interpretation of the current value of I, and I'm going to set it to I. So this is going to build a variable I1, set the value to 0, a variable I1, set its value to 1, and a variable I2 and set its value to 2. So, and then I'm going to print that out to confirm that yes, those variables actually do exist and they do have the values that were assigned to them in that statement in the for loop. Another thing you can do is we've done formatted prints using f strings, and what we can do is when we're using an f string to do a formatted print, we use curly brackets, and we typically have a variable name, colon, and then a format specifier. But one thing you can do, it is a little bit limited, But notice that in this curly bracket, instead of a format specifier, I put an equal sign. And what that will do is that will print A equals the value of A, comma, B equals whatever value is currently in 4. So this is kind of handy when you're doing some debugging and you just need some quick output that at least has minimal labeling so that you know what variable's value is being outputted for you. Okay, the next thing is merging dictionaries. So we've talked about logical operators, but there is a operator that is a vertical bar called the pipe symbol, and it means bitwise OR. So if we have the word OR, the logical operator OR, it's going to apply the truth table for A or B is true if A or B is true. In the case of a bitwise OR, it is going to take the binary value of two variables and then go through bit by bit matching bits and apply the OR operator. I personally use this a lot when I'm writing networking programs and need to do a bitwise or sometimes it's a bitwise AND, which Python has as well. So little example of this is I have two dictionaries, D1 and D2, and I give them a value, and then I say new dictionary equals D1 pipe symbol D2, and then I print out that new dictionary. And when I do that, I now have a dictionary with 4 items, and it is the combination of the first dictionary and the second dictionary. Now, one thing that you may or may not think about is what if we have repeated values? So in this case, I have 2 dictionaries, they have 2 items, and the key for the 2 items are A and C in both dictionaries. So when I do that, it goes through and it gives me just one key. You cannot have duplicate keys, or keys with the same value is another way to say that, within a dictionary. So I'm not really sure. You probably should assume it's random as to which one it takes. But in my experience, it seemed to always choose the last dictionary's key value pair when there were conflicting keys. Another cool thing is a lot of times if you're typing in numbers that have lots of digits and or lots of repeated digits or just long in general, you can put an underscore in numbers and it is basically ignored. So if I had a really big number, 39 billion plus a little, I could write my code like this. So basically I'm using underscores where I would normally have commas if I was writing 39 billion and 100. And then when I print this out, you will see that indeed that underscore was basically ignored and does not appear in my output. So that can help you make sure you don't have typos. You know, a lot of times when you have numbers, it's like, 3 6 followed by 8 zeros, and so that you don't have to count and hope you get it right. You can put the underscores in there to help you. They do not have to be where the commas are. I could have very easily written 39 underscore 00 underscore 00 underscore 00 underscore 100, and I would get the same result. Again, I use Python quite a bit in networking, and this is really handy for things like MAC addresses that are going to be 16 hex digits and are typically either divided every 2 or every 4 set of digits. But a lot of things don't want those separators in there. So you can use underscore to make sure you get the MAC address right. But then the program has just the hex digits that are representing the MAC address. Sometimes you have a list that has duplicates in it, and you would like to go through and eliminate the duplicates. So what you can do is you can take a list which can have duplicates, convert it to a set which does not allow duplicates, and then convert it back to a list. So my example code for this is this. I have repeated 1s and 2s and 4s and 5s, but 3 and 6 are not repeated. So I just wanted a mix of duplicates and non-duplicates. So then what I do is I use the set function to create a set from that list, and then I turn around and use the list function to turn that set back into a list, and then I print out the list without duplicates. And when I do that, I indeed get 1, 2, 3, 4, 5, 6 in my list. So the duplicates are gone. So super easy way to get rid of duplicates. If you were trying to do that programmatically, it would be a little more involved. There are ways that you can shorten if statements, and typically this is when you have like an if statement or an if else statement is what I'm going to show you, where the code being executed is a single line of Python code. So you can shorten that. So let's say I had a if condition, set fruit equal to apple, otherwise set fruit equal to pear. A slightly shorthanded way to do this, and a way that results in one line of code instead of 4, is this: fruit equals apple if condition is true, else the fruit is a pear. So you can go through and shorten that down to one line of code. In the print statement, we have in the past talked about end equal to control what the line ending character is, or possibly there's a space between different prints, or maybe no space at all, you just cram them together on the same line. Well, the print function has a sep equal option that does a separator between different things that are being printed out. So what I have here is end equals deals with what we're doing at the end of the line, whereas separator deals with what is printed in between values. So here I set a month, a day, and a year, and then I print those out, and I say I want the separator between these values, instead of being a single space like it would normally be, I want it to be a slash character. And that print statement would output this, the month, the day, and the year with a slash between them. Another example of doing this is we can use it to eliminate that default space that I was telling you about. So if you had a situation where you wanted to print some values but you didn't want that space between them, you could do something like this. So I set A, B, and C to the values 1, 2, and 3 respectively, and then I print A, B, and C, which would be a normal print, and then I add the separator equals single quote, single quote. So in other words, the separator is nothing. And when I run this segment of code, the first line prints as we would expect, the values of A, B, and C with a single space between them. However, if I specify a separator of nothing, then it's going to cram those values together, which sometimes can be handy. As far as initializing arrays, there are lots of different ways you can do this. I was trying to think of like multi-dimensional arrays, but you almost in Python have to know the dimensions and then iterate over those dimensions and initialize values. But if you have a list and you want to initialize it all to the same value that is not 0, or maybe you don't want to use the NumPy module, you can do something like this. So you can say my list is a single value list repeated a certain number of times, in this case 10. So I have pi, or an approximation to pi, and I want 10 of those, an array with 10 elements. So that print list will indeed print out that value 10 times, or will hold that value 10 times. This next one is maybe not super useful in day-to-day use, but there are times when you're trying to optimize your program, or maybe figure out why a program is running out of memory. So you can use the get size of method from the sys library to find out how many bytes of memory a variable is occupying. So I have a list here, X, and I initialize it like I did before, but this time the repeat factor was 100 to make it a little larger instead of 10, and then I'm going to print out the result of that get size of function. And when I do this, in this case, a array of 100 floating point numbers takes up 856 bytes of memory. So not terribly huge. That was actually a little smaller than I anticipated. But you can use that, again, like I said, mainly for debugging. So, like I said, that was just a miscellaneous collection of things that I could come up with that might be useful in Python 3.